Hi everybody, this should probably be for the second period boys in my 7th period. These are the notes for today. So fill them in. I think you guys, if you're in 7th period, are going to try to watch it as a class. So just ask the sub to pause it if you need more time. And then the filled in notes will be on Google Classroom as well. So today we're going to talk about adding and subtracting polynomials, but we're first going to talk about what a polynomial is in general. And you really have been working with polynomials all year. And so this won't be super unfamiliar, and you've actually been using some of these skills already. So a polynomial is a mathematical expression with at least one algebraic term. Oops, stopped sharing. 1 second. Okay, hopefully this will work. At least one algebraic term. So we can erase this S. So there are 2 ways to classify a polynomial: by its number of terms and by its degrees. I think degree is a little bit more popular, but we'll go over both. And so these are pretty easy to remember because you probably have used some of these words in English, but mono means 1. So the amount of terms in a monomial is 1. And so that can be an expression with an x, like 6x, or that can be just 5. 5 is actually considered a polynomial. A binomial has 2 terms. So 6x plus 3 is a binomial. X squared plus 3x would be considered a binomial. Trinomial is 3 terms. So that would be 5x squared minus 3x plus 15. That would be a trinomial because there's 3 separate terms. And then a polynomial, I'm just going to put in, that is just a variable. Polynomial with n terms. So this is, if there are 4 terms or more, there's not specific names for them. So you would just call it a polynomial with 4 terms or a polynomial with 6 terms, etc. And so an example of that would be 7x to the 15th power minus 2x cubed minus 2x minus 100. That would be a polynomial with 4 terms. But in Algebra 1, we really will rarely work with polynomials with more than 3 terms. So you really just need to know, for the most part, binomial, monomial, and trinomial. Pause there for a second. The next way to classify a polynomial is degree, and this is a little bit more popular. And so the degree is the highest exponent of any term in a polynomial. So that is the degree. So for example, constant, if the highest degree is 0, it's considered a constant. So that's like 5. 5 has a degree of 0. And the reason that is because 5, if I wrote it as 5x to the 0 power, well, we learned last unit that x to the 0 power is equal to 1. And so that highest exponent is 0, but because it's equal to 1, you would do 5 times 1, and that equals 5. And so we're not going to spend our time writing x to the 0 over and over and over again, because that just would be a waste of time if x to the 0 equals 1. But 5 is constant. Linear, and we're really used to doing linear, the exponent is 1. So if we had this linear function y equals 3x plus 2, the exponent is 1, and so that's why it's linear. And again, we don't normally write that 1 because we don't need to. Quadratic, which is what we're going to work on later this unit, has the highest exponent is 2. It's squared. So it'd be y equals 6x squared minus 5, and so it is a quadratic because of that 2. That is the highest exponent. So even if I made it 6x squared minus 5x, it would still be considered a quadratic. Cubic would be like 6x squared plus 5x cubed minus 2x. And so I actually didn't write this in order of highest exponent to lowest exponent, but you have to look, and you have to look for the highest exponent. So since it's the highest exponent is 3, that means the degree is 3, and therefore it's a cubic. And then 4 or more, there's lots of different names for these, but we're just not going to run into those until Algebra 2, so I'm not going to tell you the names for right now. But an example of a polynomial with a degree higher than 4 would be like x to the 4th power plus 2x. Technically, it's called a quartic, but again, we don't really ever refer to it as a quartic, so we don't care that much. So the main purpose of our notes today are to add and subtract polynomials. So the key idea when we add or subtract is that we're going to add and subtract like terms. So these are terms that have the same variable and the same exponent on that variable. So I'll give you an example. 4x squared and 2x squared are like terms because they both have an x and that x is squared. But 4x squared and 2x are not like terms because their exponents are different. One has an exponent of 2 and one has an exponent of 1. So you cannot combine those. Another example of, so I'm going to just X these out. Another exponent or example of non-like terms would be 4x squared and 4y squared. Yes, they both have an exponent of 2, but they have different variables. And so those also would not be considered like terms. And so again, we've done a little bit of this before, but we haven't really ever done it with anything besides just like x's. We've never used x squareds before. So I'll walk you through. I'm going to do A and B with you guys, and then you can pause and I'll show you the answers to C and D real quick, or you can go on to the next page of notes, and then I'll post all of these on Google Classroom. So for this one, we'll drop the parentheses because it's just addition. And so we're going to add 3x squared plus 9x plus 27 with the polynomial 2x squared plus 4x minus 12. So we're adding two trinomials that are both quadratic. And so because it's addition, we can just drop the parentheses. They don't really do anything for us right now. So I'm just going to rewrite this whole expression without parentheses. And then I'm going to look for the like terms. So first we have this term 3x squared, and its like term is another term that would have an x squared. So I have 2x squared, and so that's its like term. Then I have 9x and 4x, so those are like terms because they both have x's. And then 27 and minus 12, those are both constants, so they don't have any x's at all, so they're like terms. This next step you don't have to do every time, it's just good practice. It's just good to do while you're trying to get a hang of these problems, but I'm going to rewrite them so the like terms are right next to each other. So I'll write 3x squared. Because the 2x squared had a plus in front of it, I'm going to write plus 2x squared. And I'm going to write plus 9x plus 4x plus 27, and then because it says minus 12, I'm going to write minus 12. So I'm just going to do highlighting those terms. So I'm highlighting the like terms, and then I can just now do whatever operation the problem tells me to do. So it says to do 3x squared plus 2x squared, and so I'm just adding the coefficients out front. This is not multiplication, and so nothing changes about the exponent. We have 3x squareds, and then we have 2x squareds, and if we put them together, we have 5x squared. So the exponent does not change at all. 9x plus 4x would be 13x, and then 27 minus 12 would be plus 15. And so that is your final answer. So I'm going to pause for just a second to give you time to think about that. Finish writing. Okay, I'm going to do the next one, and then we'll do two more together. So this one, same thing. I drop the parentheses because we just don't really need them. And I'll get 3x squared. Oops, I didn't drop the parentheses. 3x squared minus 4 plus x squared minus 9. So the x squareds go together, and then the constants go together. So I'll rewrite this as 3x squared plus x squared minus 4 minus 9. This x squared right here has a coefficient of 1. We don't always write that down, but that's important when we add these. The 3x squared plus 4x plus 1x squared would be 4x squared. And then minus 4 minus 9 is negative 13. That is our answer for this one. Again, I will pause and give you a second. Okay, so now I want you to try C and D. So I would say pause the video right now, try C and D, and then I'm going to show you the answers now. So hopefully you did them. These are the answers to C and D. So feel free to pause this video again and check your work. If you have any questions about how I got those answers, just shoot me an email. But now we're going to go on to subtraction, and subtraction is just a little trickier. So we'll pay attention to these. So we are going to subtract the following polynomials. And so we're going to subtract one polynomial from another polynomial. And so this says subtract the polynomial 6x minus, do polynomial 6x minus 11 minus 2x minus 19. So I'm going to subtract this entire quantity, and that's going to be important. So 6x minus 11 stays exactly how it is. But from that, I'm going to subtract 2x minus 19. And so I'm going to subtract each part of that polynomial. Each term gets subtracted. So I'm going to do minus 2x, but this is the tricky part. I'm also going to subtract negative 19. So I'm basically distributing this negative side in here. But if I subtract a negative, that ends up being positive. So this turns into a plus 19. So the reason I did that is because we're subtracting that whole polynomial. So we have to subtract 2x. We have to subtract a minus 19 or a negative 19. My like terms are the x's are like terms, and then the constants are like terms. So I will rewrite that as 6x minus 2x minus 11 plus 19. That will give me 4x plus 8. Okay, we'll do one more together, and then there's 2 more problems for you to practice. And then you can work on your homework. Okay, so this one just has a lot more numbers, and so the process is the same, but it might look a little bit more confusing because we have a polynomial with 4 terms minus a trinomial, and so there's just a lot more terms to deal with. But again, I'm going to write the first term, the first polynomial exactly how it is. So this won't change right off the bat. And then I'm going to subtract the next polynomial. So I'm going to subtract each term. I'll do minus 2x minus 8x squared minus 20. And so there's no negatives in that polynomial, so it made it a little less tricky. And then I'm going to highlight the like terms. So, and I like to do these, when I actually do this, I like to do them from highest degree to lowest degree because it helps you classify the polynomial a little easier. So we first have negative 7x cubed, and this is the only one that has an x cubed, so it doesn't have any like terms. So there won't be any changing with that negative 7x cubed. Next, I'm going to highlight the x squareds. So I have a negative 8x and another negative 8x. I'm going to highlight the x's. So I have 11x and a minus 2x. And then finally, I will highlight the constants. And I'm going to rewrite this as negative 7x cubed minus 8x squared minus 8x squared plus 11x minus 2x minus 13 minus 20. So when you do this, make sure that you write the like term that appears first in the equation first. But I just wrote it, my order that I just chose was the highest exponents to the lowest exponents. So I'm just highlighting the like terms with the colors I'd used before. Okay, x cubed just stays how it is. Negative 8x squared minus 8x squared is negative 16x squared. 11x minus 2x is 9x. And then negative 13 minus 20 is negative 33. That is our answer for this one. So in the end, we have a polynomial with 4 terms that is a cubic. Okay, so take a second, pause here if you want to, and then I want you to try C and D. And then I'm just going to go ahead and show you C and D. So pause the video, and then here are the answers to C and D right here. Okay, If you have any questions, like I said, email me and let me know. And then if you're in 7th period, you should be working on your homework. And then if you are a boy from 2nd period, you are finished. And your homework will be posted on Google Classroom. So I'm going to stop this video and I'll see you guys tomorrow.